Well, good evening and welcome to Space Oddities. How are you all today? Welcome to Space Oddities on this Tuesday evening. This is, in fact, our penultimate show before Christmas. Next Tuesday, therefore, Logic Dictates will be our last show before the festivities. And we will not be with you on Christmas Eve nor New Year's Eve because it's Christmas Eve and New Year's Eve. So our next show then will be in the new year. So I can't believe that we've come to this, but we have. So happy Christmas to all our viewers. Thank you so much for joining us this year and your support and your donations and everything else that you do for us. We're very happy with you as an audience, aren't we, guys?
Oh, yeah.
Yeah, lovely.
Yeah, audience, I fancy. Yes. So there we are. So a big thank you. Yeah. Well, we'll say that probably again. But whatever you're doing this Christmas, we hope you have a wonderful time, you stay safe, and let's hope those pesky Atlantic storms don't come in again. My sister lives on the west coast of Pembrokeshire, and she said in 20 years of being there, it was the worst storm they've ever had. So fantastic. So I gather all is fine on YouTube. So let me just tell you what we've got coming up tonight. We're taking a look tonight at LISA, which is the European Space Agency's gravitational-wave detector. It will be the biggest observatory ever built, but it's in space. And it's a very, very exciting project. Unfortunately, it's still years away, but, these things take time. But we're going to give you the lowdown on the mission so that when we're all pushing our Zimmer frames around, when we cover it live, you'll be able to understand what we're talking about. So we got that. We've also got a couple of other things lined up. As you may have heard in the news, Jared Isaacman, the SpaceX astronaut, has been nominated by Donald Trump as the new NASA administrator. So we're going to have a chat about that and see what different people's views are, because obviously, people don't get nominated as NASA administrator every day. So it's quite a big event in the space industry. So we're going to have a chat about that. We're also going to be talking about the actual cost of spaceflight, because what happened this week, as you may have seen, is that a SpaceX booster has reached a record number of reuses. It's now flown 24 times, the most ever for a booster. Let's hope it gets to more, because I think SpaceX said that they don't see any reason why those boosters shouldn't last for 100 launches with refurbishment. So we got chatting about the whole thing of reusable space vehicles bringing the cost down. So we're going to tell you a little bit about exactly how much and when. And we've got some other things lined up as well. But obviously I need to give the normal greetings. So with me this evening is Roger, looking splendiferous in Sparkford, as ever.
Of course.
Of course. And we've got Daz. You may not know this, but when Daz was younger, he won the Mr. Universe competition.
No, I was Mr. Ribena. I won at Butlins, the Mr. Ribena contest. And if I can find it, I will show you the picture of me when I was about 7 or 8, and I won the Mr. Ribena beef.
Well, Dad did win the Mr. Universe contest. Unfortunately, wasn't in this universe. But there we are. Michael is here doing his Stan Laurel impersonation. So how are you this evening, Michael?
Fine, thank you.
Good. And Ian's here again. How are you, Ian?
Hello. I'm good. Yeah, thank you.
Yeah.
Question too hard.
Yeah. And lastly, we have Lou. Now, Lou, would you like to tell us where you are this week?
I wish I knew, Andy.
Oh yeah, I know how it goes.
I'm in a hotel room in Washington D.C. for the American Geophysical Union annual fall conference, and we will be talking about that a bit later today.
Fantastic! And how many people are there, Lou? Did you say?
I heard the count is 27,000 nerdy scientists. Wow. Scientists.
I wonder what the collective term for that is. There must be one.
Is it a gaggle?
No, it's a gaggle.
Gaggle.
A boredom.
It's a score of scientists.
A score of scientists.
A wisdom.
Scientists. An equation of scientists.
An equation.
perhaps our audience could help us with this.
Yes, if you've got any term for what's the collective noun for a group of nerdy scientists, all 27,000, please put it in the chat. So talking in the chat, let's have a look and see who we've got in tonight. So Kenneth's here. Hi, Kenneth. Jerry's here. Hi, Jerry. Who else have we got? Gerard's here. Evening. How's the Wirral? Hope everything's okay in the Wirral. Your weather's okay. And we got Derek, of course. Mm-hmm. And thank you so much for your donation, Gerard. Already, you're always fast in with your donations. Thank you so much, much appreciated as ever. And as you know, every bit of money goes towards keeping the channel running, so that every tiny bit helps, and every big bit helps as well, of course. So, you know, if you can only do the tiny bit, then that's fine too. Okay, just some usual housekeeping.
I just want to say that I think. Oh no, sorry, it's moved. It slipped.
Yeah.
Derek compared me to Homer Simpson.
Yes, I can see that. Okay.
Yes, I just and Ian's confessed to being Bart.
Yeah, yeah. And thank you, David. Much appreciated, David. Yeah. So thank you so much. Fantastic. Okay, usual things. We'll just quickly run through the merchandise. The Space Oddities shop is open 24 hours a day. And you can buy your Space Oddities t-shirts and hoodies there. The t-shirts are £25, including UK postage and packing. The hoodies start at £40, including UK postage and packing. And if you are outside the UK, please add £10 to the total value of your order to cover foreign postage. So that's that. That was quite easy. If you wish to support us, you can, of course, click the super chat icon underneath the chat window there. But you can also buy us a coffee, and you can scan the QR code here. We are still trying to resolve the issue of the link for this not appearing in the chat with our software supplier. They've been working on it since September. So, you know, give them a chance. So we hope to have that resolved very soon. In the meantime, if you would like to support us, you can scan the QR code there and go to the Buy Me a Coffee website, where you can make a donation towards our caffeine supply. So there you are. So I think that's about all the housekeeping. Obviously, we'd also like to say keep the photos coming into the gallery, because until we put out an urgent plea on Facebook for images, we only had 2. I know the weather has been terrible and nobody's been out taking images. There have been no clear skies anywhere. But, you know, if you do have astronomical images that you'd like to share with others in the gallery, then please address them to gallery@spaceoddities.space, gallery@spaceoddities.space, 1 image per email, please. And tell us all about the image and, you know, what equipment you used and exposure and all that sort of stuff. And there you are. And don't forget the Space Oddities website. The Space Oddities website, which is actually up and running, has been for a couple of weeks. You will find, going forward, all of the gallery pictures, as well as being here on a Tuesday, they are in the gallery on the Space Oddities website, the address of which is https://spaceoddities.space, as you can see on the screen there. Don't try www.spaceoddities.space, because that will not work. It's a secure address, https://spaceoddities.space. So there we are. And just to remind you to send your gallery entries in, please send them to gallery@spaceoddities.space. If you would like to email us in connection with anything else, please address your emails to info@spaceoddities.space. If you just want to drop us a line, because we get lonely sometimes. And, you know, if you want to drop us a line, any feedback, suggestions, ransom note, you know, things like this, death threats, that's fine. Just put it in an email to info@spaceoddities.space. So, and thank you very much. And also, very important, don't forget to like, subscribe, and comment. And we see that our videos normally in the comments on YouTube. That's not in the live chat that you see here after the video is published. We don't get that many comments. And the YouTube algorithm uses the number of comments we get to decide whether to recommend our videos to people, and if it doesn't see any comments there, it thinks nobody's interested, so our videos don't get recommended. So just leave a comment. It could be anything, saying fantastic, or at the other extreme, absolutely ghastly. And any comments, whatever. YouTube doesn't care what the comments are, it just counts them. So please do remember to leave a comment if you could. That would really help us out a lot. Okay, that's the housekeeping over. Let's move on. So what we're going to do now is to go to the news, first of all. So just let me set myself up here, and we'll go straight to this week's news. Okay, so what's in the news this week? Well, we've got a few things. The first thing is that there's been a new confirmation of one of the figures of the Hubble tension. Now, if you've been watching the last couple of weeks, Lou has very kindly elucidated about dark matter and dark energy, and he's talked about the Hubble constant. So I just want to come up with, tell you about some new developments in this. And there's a new paper out which has looked at, basically since the JWST was operational, the last 2 years, and it's been used to calculate the Hubble constant. And if you don't remember what it is, the Hubble constant is essentially the measurement of how fast the universe is expanding. And it's measured in the number of kilometers per second per megaparsec. So it's 1 million parsecs, and 1 parsec is 3 point something light years. And the Hubble constant, as put forward, believe it or not, by Edwin Hubble, is the measurement of how fast the universe is expanding. And one way of doing that, which Lou mentioned, is to use Cepheid variables. These are stars that have an intrinsic brightness. So basically, if you measure the brightness of the star, because they're all the same, put simply, then you can measure how far away they are. The distance, measuring the distances to stars is not that easy, but the new data is that the Webb has managed to pin down the distance to these Cepheid variables to an accuracy of 2%. Is it somebody's beeping a lot there? Who's beeping?
Yeah, I thought that.
Yeah.
That's me.
Right. Stop it. Yes. So it's measured the accuracy to within 2%, whereas the Hubble Space Telescope, being a sort of, I'm not going to call it an inferior instrument, because we all know what a fantastic instrument the Hubble telescope is, but it could only manage an accuracy of 8 to 10%. So what difference does this make? Well, let's have a look. So here's a graphic about the Hubble constant. The Cepheid variables are just one way of measuring it. You've also got distant supernovae, you've got giant red giant stars, and you've got the cosmic microwave background, which is the leftover energy, if you like, from the Big Bang that traveled across the universe about 380,000 years after the Big Bang. So the Planck satellite measured the age of the universe using the cosmic microwave background, and thus how fast it's expanding. And the Planck satellite gave a figure of 67.49 kilometers per second per megaparsec. Unfortunately, it's at odds with some other measurements using gravitational lensing is about the same, 66.6. If you use red giant stars, you get a figure of 69.6 kilometers per second per megaparsec. But using Cepheid variables, which the JWST has managed to do more accurately than ever before, you get a figure of 73 kilometers per second per megaparsec. So in other words, depending what method you use, you get a different figure for how fast the universe is expanding. And this shouldn't be. They should all give you roughly, if not exactly, the same measurement. And this is known as the Hubble tension. I won't go too much into this now because Lou has mentioned this the last couple of weeks. But what does it mean? So basically, on the left here, you've got Cepheid variables, supernova explosions, and red giants. All of these are methods of measuring how fast the universe is expanding, and that gives you a figure between them of between 72 and 73 kilometers per second per megaparsec. Now, on the right-hand side, you've got gravitational lensing and the cosmic microwave background, which are giving figures between 66 and 68, and this is the Hubble tension. Astronomers cannot work out at the moment why there is this discrepancy. And it just goes to show that we actually may not know as much about the history of the early universe as we think. Because if you put this another way, on the left, you've got, it should be in inverted commas really, the young universe. And on the right, you've got ways of measuring really, really ancient light from the very, very early universe. So what this could mean is that the universe was expanding at a rate in the early universe different to what it is today. This could be one solution to the Hubble tension. But hang on a minute, because what about dark energy? Now, Lou very nicely told us about dark energy. And surely, because we know that the expansion rate of the universe is accelerating because of this mysterious whatever it is called dark energy, we would expect the expansion rate in the early universe to be less than what it is now, or more than what it is now, depending on how you measure it. But it should be different because of dark energy. So that's sort of expected. But what we think we know about dark energy is that it didn't actually overcome the force of gravity until about 6 billion years after the Big Bang. So it should not have made a difference to the expansion rate in the first 6 billion years of the universe. And there the mystery lies. Don't know the answer to this, but it does seem to be indicating more and more that we don't know as much about the history of the universe as we think we do. So interesting times, but I just thought I mentioned that because it is a new bit of data confirming this figure of around 73 kilometers per second per megaparsec. Okay, let's move on. Okay, guys, question for you. What's missing from this image?
The moon?
No, not the moon.
An astronaut?
No.
Is it Andy?
It is. Yeah. Yeah. How did you work that out? You're so clever, Lou. Yes, absolutely. Yes, I am missing from that image. Obviously, no. Obviously, it's not me. Any other thoughts? If you've got any ideas in viewers, put them in the chat. Perhaps somebody could read them to me because I can't actually see the chat at the moment from what I'm doing. So, any suggestions missing from this image?
Is this what have we got to put the missing football in?
Yes, it is spot the ball. You're quite right. Yeah.
Spot the ball.
Spot the ball.
Derek
Yeah,
says,
it's a cosmic
Derek
spot the
says
ball.
stars.
Sorry?
Derek says stars. Derek says stars.
Derek is exactly right. Well done, Derek. Of course, the stars are missing from this image. So where are they, guys?
Well, the black
Yeah,
parrot,
two
maybe, yeah.
phones.
The dynamic range isn't big enough.
Yes.
Can you explain that a bit, Roger?
Well, the photograph that this is already taken of is so brief that the faint starlight that would have been in the sky wouldn't show up.
Yeah.
Okay, and why does the photograph need to be so brief?
Because of all the
'Cause it'll all get burnt out.
it'll
won't it?
just
Yeah.
be
The
overexposed.
Absolutely. If you expose for the stars, the bright objects in the foreground will be completely overexposed.
That's correct.
Yeah.
So you cannot expose for both at the same time.
That's right.
That's why there was such a conflict why people couldn't see the stars when the Apollo astronauts were on the moon.
Yeah, that's right.
That's right. And this
Derek hit the nail on the head.
yeah.
Yeah, exactly.
And this image, of course, is used these days by idiot flat earthers to claim that this is a fake photograph.
Oh dear.
Yeah, of course.
Lord, right.
But, they don't ask the obvious question, why would NASA forget to put the stars in there, or SpaceX forget to put the stars in there? The reason I'm showing you this is because of this.
Oh yeah. Right.
Oh, yes.
Yikes.
Taken,
Yeah, I saw that picture. Brilliant.
This is taken at night of, I should say, when it's on the dark side of the Earth, if you like, during the night of the Dragon spacecraft. And just to illustrate,
Yeah.
there's this lovely video of, if you could be there, this is what you would actually see.
Yeah.
So the stars are not missing. It's just that you cannot expose your photograph for the bright spacecraft and the stars in the background at the same time.
Basic photography, that is.
Basic photography, but apparently there are many people who can't grasp the simple concept.
No.
Looking at anything to do with space on social media, this invariably comes up. Well, there are no stars, it must be fake.
Yeah.
And now the Dragon goes into sunlight.
Yeah.
Disappear, isn't it?
And this is where it starts to bleach the sky out, of course, because now it's overexposed.
Yeah.
And that illustrates the point perfectly.
Yeah.
So there you are. So I just thought I'd mention that. I thought that was a lovely video of the Dragon and the stars in the background, just to prove they're there. Okay, another question for you then. So well done to Derek. You get brownie points there, Derek. Okay, what is this photo of?
I would say a volcanic explosion, or maybe, I would say almost like a quarry explosion.
Yeah, it looks like a quarry explosion. And
Yeah.
in a way, it sort of is. This was the European Southern Observatory blowing the top off a mountain so they can build the extremely large telescope there.
Yeah.
This was a few years ago. So I wanted to show you this because there's a new image of the extra large telescope, the world's biggest telescope with the 39-meter mirror, under construction in Chile. And I just thought we'd go through a few images showing the history of it. So that was the initial thing that they did. They leveled the top of the mountain to create a flat, perfectly flat area for the telescope. The next thing they did was to build an access road and dig the actual bit in the ground where the foundations would go. Then they put the foundations in with all this rebar. The next thing, they started building the structure, concrete and steel structure, and it's come up really well over the last few years. There it is, looking good. Even more development, and now the latest image. Do you want to see how it's going now?
Wow.
And there you are. This is the latest image from the European Southern Observatory of the extra large telescope, and this is how it's progressing in Chile. And as you can see, sorry,
just a quick comment. This is the ELT, right?
Yes.
Okay, so I think this is the extremely large telescope, not to be confused with the extra large telescope or the very large telescope, or the sickeningly large telescope.
Yes.
Which hasn't been built yet.
Not to be confused with the OWL.
Yeah.
Overwhelmingly large.
The overwhelmingly large telescope, which
we're going to run out of adjectives for these things.
Yeah, I know. Yes, sorry, that was a mistake, not the extra. The extremely large telescope. Extremely is obviously bigger than extra. So, so this is the world's biggest ever optical telescope. It's optical and a slight bit of near infrared, and it's under construction in Chile. First light, we hope, is going to be in about 2 years. In about 2026, they hope for first light. But looking at this, the project is coming on amazingly fast. They've got a sizable bit of the actual dome built. The lengths they had to go to design this, to protect it against the elements, is absolutely unbelievable, and that's a story in itself. But if you go to the European Southern Observatory site and go to the ELT site, I can't remember there is a direct way of getting there, but I can't remember what it is. There's a fascinating lot of articles about exactly how this was designed. This promises to revolutionize Earthbound astronomy. It will have a resolution It's said about 15 times more than the Hubble Space Telescope. So we're guaranteed to get amazing images when it's complete, and stands to make major discoveries. If all goes well, this telescope will be able to image planets orbiting other stars directly. So we'll be able to.
Yowza.
Yeah. This is how amazing this telescope is. Well, it has a 39-meter mirror. It was going to be 43-meter mirror originally, but Europe started to get cold feet over the cost, and they realized that just by taking the outer ring of mirror segments off, they could save €1 billion. So they trimmed it down to a 39-meter telescope. It's still made up of 798 segments, that mirror, each controlled independently, and it's going to have the most advanced assisted optics ever. So we're really looking forward to seeing this European project see first light in about 2 years. So there you are. Just thought I'd share that with you. Okay, Orbex have been in the news. Orbex, if you don't know, are a rocket company who have put up a lot of the funding and the impetus behind the Sutherland Spaceport in Scotland. In a shock move, they have pulled out of the Sutherland Spaceport, and they have declared they are moving to Saxonwold, which is the Scottish spaceport that we've talked a lot about on Space Oddities, the Scottish spaceport in Shetland. And they've caused a lot of local anger because the Sutherland Spaceport is basically now being mothballed. There have been calls for a public inquiry because £15 million of public money has been sunk into it, and it now looks like it's not going to happen. The local crofters have they've been receiving, for the lease of their land, £70,000 a year each for the lease of their land. And the Scottish government has announced that because it's basically a contract, they're going to continue to get that money. So they're quite happy. But on the other hand, it's a lot of people really angry. Anybody got any thoughts on this?
Yeah, it's a real shame.
Well, it's a bit of a shame, isn't it? If it's being totally mothballed. I don't know how advanced it was as a launch site.
They hadn't even finished the access road, so
yeah. So it's not going to be. It's just basically the money that's been spent on developing this and getting it through planning and everything else.
Yeah.
I mean, maybe it can be re-envisaged as possibly a space hub or something. Because I don't know if many. Because usually in fact, the space hub, I think there is a hub around that area, but it's away from the actual launch site.
Yeah.
Because you can't have a hub on the launch site. So, it's such a shame, but there you go. It's
and of course, Saxonwold.
Yeah, I was going to say, we still got that.
So far ahead, isn't it? You know, in their development.
And the thing is that Orbex, what's upset a lot of people is that Orbex have not exactly specified why they pulled out.
All right.
They haven't really given a reason other than it fits in with their strategy and all the normal corporate bullshit. So we really don't know exactly the reasons. However, you know, it's as far as they're concerned, because they're busy constructing their first launch vehicles. And in fact, we did have a gentleman from Orbex come and speak to us on I think that was on Space Oddities, or was it Astro Radio? Can't remember.
Yeah, we also had Skyora as well, didn't we?
We had Skyora as well. Yeah,
that's true.
Yeah, another company. But not good news for Sutherland, because obviously that would have stimulated the local economy, created jobs, etc. But Orbex obviously, for whatever reason, decided against it. So it's sad to see Scotland potentially losing a spaceport, although there is a great effort at the moment to attract other companies to use it. So it may not be the end of the spaceport, but for now, until they find somebody to use it, it's in mothballs and construction will not proceed. So there we are, a bit of a sad day. Okay, now, gravitational waves. Well, you're probably bored with this, but we've talked about gravitational waves quite a bit on Space Oddities because it's exciting. Who wouldn't be excited about this? Been some new findings. Now, first of all, just you've probably seen this before, but this is just a reminder, a refresher, if you like, of pulsar timing arrays. And just very briefly, what this is all about is that the pulsar timing arrays are essentially radio telescopes that look at millisecond pulsars. These are pulsars spinning up to 1,000 times a second. I think the record holder is 787 times a second, if I remember rightly. But anyway, not to worry. The idea behind this is that as gravitational waves travel the universe, they delay the signals from the radio signals from these millisecond pulsars. These are already extremely accurate clocks. They rival, long term, they rival atomic clocks in their accuracy. So it's possible to detect if the signals are delayed by the time they reach the Earth. If they are delayed, then a gravitational wave which stretches space and time has been responsible. You have to do this over a very long period to make the measurements. Last year, as you may remember, we talked about it. There were several groups involved in pulsar timing arrays, and one of them announced that they had discovered that there is this gravitational wave background in the universe, a constant hum, if you like. This was borne out by all the other groups, that they detected it too. And we're not quite sure where this gravitational wave background comes from, this constant hum in the background of the universe, if you want to describe it like that. There are two main possibilities. They either come from supermassive black holes, that is to say, pairs of supermassive black holes co-orbiting at the centers of galaxy mergers and radiating away gravitational waves, or there's a possibility that they could come from the primordial universe. The evidence so far is coming down on the side of black holes, but there's been an interesting development with this, which I will now share with you. And what that development is, first of all, the South African telescope MeerKAT, the radio telescope that is a precursor to the Square Kilometre Array, the biggest radio telescope ever to be built, under construction now and until the end of the decade. This radio telescope spanning Australia and South Africa will be the most accurate, most sensitive ever made, about 1,000 times more sensitive than any existing radio telescope. And they have confirmed the observations that were made over 15 years by the pulsar timing arrays. They've confirmed it with only a year of data, which just goes to show what a wonderful telescope it is. They need more time, but initial readings after a year of observations with MeerKAT indicate that that gravitational wave background is confirmed. It's definitely there. And more to the point, what this has enabled them to come up with is this. This is the first ever map of gravitational waves on the sky, where they're coming from, which is an incredible achievement. And as you can see, obviously the stars here, the white stars represent the pulsars. So there are more gravitational waves in the southern hemisphere of the sky because that's where the pulsars are observed from, the southern hemisphere. So they haven't done the same thing for the northern hemisphere yet, which is why you're seeing greater densities of gravitational waves in the southern hemisphere. But if you look right at the bottom of this, you can see that there is a so-called gravitational wave hotspot. In other words, there are more gravitational waves coming from that direction than anywhere else. This at the moment is not statistically significant. It could be down to a number of different factors. They're not saying it's real, but on first look, there appears to be a gravitational wave hotspot right at the bottom of the southern hemisphere, almost at the pole. So that's interesting. So what do you think of that, guys? I never thought we'd see this, a map of gravitational waves. I think it's amazing.
Yeah, it certainly is. And what we need to do is get some pulsar observations in the northern hemisphere.
Indeed.
To complete this map. That'd be fantastic. But of course, both these square kilometre array and MeerKAT are southern hemisphere things, aren't they? So
they are.
We need a big radio telescope array in the northern hemisphere then.
And of course, you know, one of the reasons why that has not been done is because there's far less radio interference in the sun.
Exactly, yeah. Less population and that.
Exactly. So, but I'm sure it will be done. Interesting to see what the square kilometre array comes up with.
Couldn't they do a space telescope? Couldn't they do it in space? Couldn't they do it in space?
Well, it's funny you should say that. We're going to talk about that very thing this evening. So there we are. So thank you for previewing that nicely for us. Okay. So that's the news for
Andy, before you take that off screen, can you go back to the what's missing from this image presentation and show the video towards the end? And before you start it, let me just explain why. When the actual spacecraft starts to burn out and we're coming towards the end of the video, there's an artifact that moves from the top to the bottom in quite a fast thing. I'll see if I can point it out to you. So we'll wait until it actually starts to black out. I mean, it could be just another satellite or something in the background.
Yes, I read about this. I think they're Starlings.
Oh, okay then. But if you look at it, it's to the left-hand side of this image.
Hang on, I'll just fast forward.
It's almost right to the end. Something comes. There it goes.
And another one there.
Oh, there goes another one across. Yeah, so it must be. Yeah.
Yeah, I think.
I only saw the one the first time. Yeah, aliens.
Don't start that. Somebody will take you seriously, Dad.
They're skipping across the flat Earth,
which, as we know, is always a mistake. So there we are. So there we are. That's the news for this week. And,
thank you, Glenn. That was good.
Any questions? Anything you want to say, viewers? Put it all in the chat, and we'll do our best to answer your questions. So what we're going to do now is we're going to go. Yes, I know, Roger. He's so excited.
So excited.
He's like a hyperactive puppy. He really is. So
just like
be on the floor.
At my age, definitely.
Yeah.
You're not old, Roger.
Yeah, absolutely.
I know. Young at heart.
All right then. Well, let's go over to Roger then. Roger is going to take us through what's up in the night sky and this week's gallery. So take it away, Roger.
Okay, so here we go through the first half of the month already, and where are we going? So we're heading towards a full moon towards next week. That's where we're heading, and that's not good news for something which is going to be coming up in a minute. Spoiler alert.
Oh dear.
Oh yes, I know. So during this coming week, I've got this at midnight. So as you can see, we've got the glorious constellation of Orion facing the in the southern part of the skies, and that's all the better for reminding us of the December month which we've got. And we've also got a few of the planets, although Saturn at this point has pretty much set. But we still have Uranus, Neptune, Jupiter, and Mars all there to keep us occupied. And so there we go. Right, let me just move on. And of course, just before sunset, we've got Mercury setting just before the sun. And we've also got Venus there in the night sky, which is beautifully displayed after sunset in the southern horizon. And as you can see, Saturn is gaining on Venus's heels there. So we are getting to that time of the year where Saturn is becoming less and less of an object, but we still love planet Saturn. So there we go. Okay, so we have a few matters. Matters of interest. We've got the Clair Obscura on this evening, should anyone be able to get a clear sky, to see the jeweled handle, or Sinus Iridium, as we all like to know.
By the way, thank you for labelling the moon on the right there.
I know. Yeah, well, I like to state the obvious, just to make sure. There is no room for disinformation on what that is.
That's no moon.
That's no moon. But on Friday the 13th, we've got the Pleiades and the Moon together. Being as it's so near to being full, it's going to drown out the Pleiades, unfortunately.
Exactly the same
as it does.
Yeah.
Which also means on Saturday the 14th, we've got Jupiter with the Moon, and we've also got the Geminids. Whether we'll see any bright meteor showers near the full moon is all well and good. And good luck if you can spot anything. Typical, isn't it?
Yeah, I think over the next week, the next few days and the week is Scotland's only the ones with the clear skies, but of course then they got to contend with the moon.
And then we've also still trying to keep an eye out for T Corona Borealis, which has yet still to prove its brightness improvement. So we'll see about that. But might be in the new year.
It's a disappointment.
Somebody got their calculations wrong. Anyway, no doubt it'll be a cloudy night. So we do have a few Jovian transits over the next week or so. So here we've got one of Ganymede on the 16th. If you want to be about 3 o'clock in the morning to watch that, but you've also got the great red spot there as well. So that would make a good photo opportunity. And during the just before sunset at 20 past 4, we've also got Rhea's transit. So that will be a great challenge for anyone who wants to do that.
Yeah, I was going to say that's a bit of a tiny shadow, isn't it?
Well, yeah, you really need quite a decent aperture to get the resolution to even see that. But there we go. Gauntlet thrown down.
And there's one. Could you go back, Roger?
Yeah, I thought there's two there, isn't
just
there?
in the upper left of that, there's unless there's some dust on my screen, I see another shadow. I think. Do you see that?
That's probably just the shadow of the disc on the rings there, isn't it?
Well, isn't there another spot just below the rings?
That is Rio that is ringed round, and then you've got the spot which is.
Oh, sorry. Yeah. Okay. Yeah.
I mean, they've ringed the moon there, and then you've got the shadow which is over to the left there.
Yeah.
That's confusing.
And unless I'm wrong, which is not unknown.
Not Andy.
Yeah, I know. It's a difficult concept.
I know.
But if you look towards the back of the rings on the left, I think that may be Enceladus, just above the ring there.
Well, on the left-hand side?
Yeah, on the left-hand side.
Yeah, I think that may be Enceladus. Anyway, doesn't matter.
Can we move on now?
Yeah, please do. Carry on.
Ooh.
I'm so glad. Right, we have now got a decent quantity of images in this week's gallery. And the first one is from our very regular Jerry DeLay, and he's got the Heart Nebula in Cassiopeia, a 2-plane mosaic. And this is what he's posted in.
Oh, wow.
That's really nice.
There we are. We've got the heart, and then we've got the fish head down below it there.
Yeah, lovely.
That's amazing colour, isn't it?
Well done. And then we've got Melot 15 in the middle there, which is one of Rachel's favourite targets.
That's right, yeah. Yeah.
And then we've got another regular from Michael of the Large Magellanic Cloud. So there we are. Not as seen from Ireland, or when you go to Australia.
Yes.
There we go.
Oh.
Yeah.
Oh,
I don't see that very often.
No,
yeah.
that's not.
But never seen that yet.
That was done with a 1100D camera and a 50 to 250 at 100mm lens. So just basic photography equipment, really. Due to the large size of the object.
Yeah.
So I guess that would be about the same sort of size as the Andromeda Galaxy.
Yeah, probably. Yeah.
There you go.
And one of the moon from me, just as you do. Now this one's a bit of a soft focused effect because the weather was
soaring up a body.
Hmm. Is that Michael doing his Fred West impersonation?
Oi!
Apologies, viewers. I've no idea what.
This was a misty, murky moon, so this was the best I could do for a little while ago. Right, now on with the more interesting objects that we have from Lou, and this was done with an 18-inch star splitter Dob. There we go, and this was close.
Oh well done, Lou.
That's lovely.
Oh, yeah.
I got lucky. It's easy to do this with the moon. The moon's bright, so it's easy to find in your cell phone. I tried doing this with Jupiter. Jupiter was amazing in my Dob. I could see structure in the belts, but I couldn't find it. I couldn't hold the camera right, so just.
The adapters are easy and cheap enough to do, Lou.
Oh, yes. Well, I put a little 3-axis cell phone holder on, and I still couldn't find it.
Oh, there.
Oh well.
More practice.
More practice.
More practice. And just to cop it off, he's also done a Horsehead Nebula with his 5-inch Explorer Scientific. Da, da, da.
Oh, that's nice.
That's really nice.
Different orientation.
Yeah.
Well done.
Had to stop had to stop it early because the clouds were rolling in. I think we're getting some effect.
Yeah, they do that. Pesky clouds. Okay.
Oh,
lovely.
That's great.
Right. Oh, here's one of Ian's processed Juno images of Jupiter. And this is what he's come up with.
Very nice.
That's nice.
He's
Wow.
this.
You just fiddle
That's really
around with the. You just fiddle around with the settings and see what happens. That's what comes out. So it's good.
Yeah.
I should have given you the original, but never mind.
There's
That's
a lot of
blurry.
there.
Very good.
There is. Isn't
Yeah.
Yeah, absolutely amazing structure on that.
Jupiter is looking more and more an unfamiliar planet thanks to Juno, isn't it?
Yeah. So I've got a few here from Ken, and this is North American Nebula. And this was 119 30-second exposure with his little Canon EOS Mark 135 Samyang. And this is what he's managed to produce with that.
Oh, Kenneth, that's wonderful.
That's great.
Breathtaking.
That's really good.
It's come out all right, isn't it? And
It's come out perfect.
the pelican there.
Yeah.
Yep.
Yeah.
You're getting the hang of this.
Yeah, very good.
And, he's also got one of the Cygnus Loop while he was in the area, and similar setup. And we've got a really wide. We've also got some of the Pickering Triangle there as well.
Wow. That's
What is this called again?
Pardon?
Veil.
This was just done with a APS-C camera.
It's called the Cygnus Loop.
Yeah.
Well,
Cygnus Veil Nebula.
Yeah, that's the Eastern and Western Veil nebulas in Cygnus there.
That's nice.
And you got the Pickering Triangle in between it.
Beautiful.
That's amazing.
Yeah.
Oh, see.
Wide angle. And just to finish off with Kenneth's images, he got Orion with the M42, the Horsehead and the Flame. And he was trying to get some images there. We've also got the 135 Sigma and his EOS 50 Mark II and an Optilong L Extreme. So he's trying to work out how to get this all done. So he's working on it.
That's nice.
That's really nice.
You just about got the 3 belt starts there. You just slightly cropped
just on the top.
Got the image coming quite well there.
Beautiful.
Bit more processing there, Ken, and you'll be up with it. It's very tricky when you try to expose for the Horsehead and the Flame. You sort of burn out the Orion Nebula there, so you've got to sort of do a little bit of blending, but he's done very well with that.
Yeah, very well.
Didn't he do well?
He did. So that concludes for the gallery tonight.
Can I just leave that one up a minute, Rog? I'm looking at this on two different screens.
And
But on one screen, it's a bit darker than what I'm seeing on the Restream. And with that, with the definition, I mean, it's a lot darker, so you can see the colors and the clarity. You can almost make out the trapezium in the center of
yeah, I know.
it's not been burnt out. It's really good.
Yeah.
Yeah, you can almost make out the trapezium, the four bright stars in the middle.
Yeah,
very tricky with that bright contrast.
Kenneth actually says, yes, that's true. Burn the trapezium, though, he says.
That's nice.
Yes.
Yeah.
Well done.
Okay, well done, Kenneth. Okay. Well,
I've got some more of his, but I'm keeping it back for next week.
Okay. Okay. Well, thank you very much, Roger, for that, as always. Hang on, I've got my camera off. Just turn my camera back on.
Oh.
No, that's much better.
Camera off.
Yeah.
No. There we are. Bought it now.
Living colour. Anybody who says the avatar was preferable will be dismissed immediately. So there
Bye.
So, bye. Nice knowing you. All right. So there we are. So Ian's there he is. Oh gosh.
Hello. What's happened?
So there we are. Okay. Right. Let's move on. So we talked about gravitational waves in the news, and we're going to return to the topic of gravitational waves now, because we're going to talk about LISA, which is the European Space Agency's mission to detect gravitational waves. So let's talk about, first of all, we're going to come onto the actual spacecraft, but before we do, let's talk a little bit about the physics behind it, if you like. What's it all about, basically? Now, you've probably seen this before. I have shown this a few times, but just a quick revision. This is gravity's spectrum. This is the wavelength, or the frequency, if you like, of different objects that emit gravitational waves. At the moment, the Earthbound detectors LIGO, Virgo, and CAGRA are detecting merging black holes, and they're detecting merging neutron stars, and there have been a couple of tentative detections of a neutron star colliding with a black hole. I don't think any have been definitively confirmed yet. This is all very, very difficult things to do. But they sort of, in frequency, in hertz, they go between all those objects, between 1 and 100, which is the only range that Earthbound gravitational wave detectors can detect at the moment because of their size. And to detect lower frequencies, you need bigger gravitational wave detectors, basically. Then we go down to what is not currently within range of the current generation of detectors. And, I'm sorry about that. We go down to from 1 down to 10 to the minus 4 hertz, and we're looking at really compact objects captured by supermassive black holes. So these would be, if you like, stellar mass black holes and neutron stars orbiting supermassive black holes. Also, binary supermassive black holes in the centers of galaxies. These would occur because of a galactic merger, where you have two galaxies coming together, each with a supermassive black hole, and when the galaxies merge, the supermassive black holes come together and start orbiting each other, and as they get closer and closer, they emit low-frequency gravitational waves, possibly quantum fluctuations in the early universe, though, at these lower frequencies. Then we move down, whoops, wrong way. Then we move down to 10 to the minus 8, and this is where the pulsar timing arrays come in. This is the range in which they operate, 10 to the minus 8 hertz. These are the frequencies of gravitational waves that is being detected, delaying the pulsar signals reaching the Earth, as we mentioned earlier. And then we go right down, whoops, sorry, I'm all fingers and thumbs today. Let me go right down to 10 to the minus 16. And this is really early universe stuff. And these will be found in the cosmic microwave background. So we expect that they would leave some sort of imprint on the cosmic microwave background, but currently not able to detect them because of there's such incredibly low frequencies. So looking at it another way, we've got a vertical scale here. Right at the top, we've got our pulsars. We've got supernova explosions, which also would generate gravitational waves. We've got binary neutron stars and binary black holes. So this is where we are at the moment with our current detectors. Notice that the period, if you like, of those waves is measured in milliseconds. Going down, we've got the binary supermassive black hole merger. The period of those will be measured in hours. But as you go further down the scale, you get a longer period, which goes down to millions of years. So if we were ever to detect the inflationary period at the beginning of the universe, for example, its period of the waves will be measured in millions of years. So you would only detect one wave every million years, which shows how far out of our detection it's going to be, because obviously nobody's going to wait around for a million years to detect another wave. But I wanted to show you this because this is an illustration of the fact that we're not able currently to detect lower frequency gravitational waves from such things as binary black holes. And this is raises another question. Notice we've got supernovae there. Although they are within the range of LIGO and the others to detect, we're not detecting them. And there are several reasons for this. And one of them is that these supernovae, obviously supernovae don't happen that often, about once every 50 years in our own galaxy. So it's no surprise that we haven't actually detected them yet, because supernovae are actually quite rare. The distance and sensitivity means that the sensitivity to gravitational waves from supernovae requires them to be relatively close, within a few 100 million light years. And most supernovae we detect are much further away from that. So they are out of the range of the current detectors, if you like. These signals from supernovae are extremely complex and can vary significantly. And it makes it very challenging to extract a clear supernova signal from the data. And also background noise is always a problem. This is seismic noise from shaking on the Earth, if you like, thermal noise and quantum noise, and these can actually mask the signals from supernovae. So it's not that easy. Also, rotating neutron stars. This is known as this is constant noise as rotating neutron stars rotate. If they've got a slight bump on their surface, and the biggest bump you can have on the surface of a neutron star is about 2 millimeters, thanks to the extreme gravity, that will be classed as a mountain on a neutron star. If there were a bump a couple of millimeters high, we'd need to detect one neutron star that had this bump, that was gravitationally generating these waves, because otherwise they don't generate gravitational waves. They only generate gravitational waves if they've got a bump. So this is probably why we haven't detected them. The frequency is also requiring long observation times and sophisticated data analysis, and again, background noise. So this explains why we think we haven't received signals from supernovae explosions or rotating neutron stars. So the objective of LISA is to detect gravitational waves from compact object collisions like binary black holes and neutron stars, as well as objects beyond the current capabilities of LIGO, Virgo, and CAGRA, merging supermassive black holes, as we said, compact objects orbiting supermassive black holes, as I said, black holes and neutron stars orbiting supermassive black holes, and quantum fluctuations from the early universe. So that's the sort of objective of LISA, is to detect things that are currently out of the range of the Earthbound detectors at the moment. So that's the sort of the science behind it. Michael is now going to tell you a little bit about the spacecraft, the LISA spacecraft themselves, because there are 3.
Yes, I am.
As he's getting ready, Andy, just a thought. You had some beautiful graphics here. One showed variations in frequency.
Yeah.
One showed variations in time.
Yeah.
And the one that I thought I wanted to see is variations in length. Of course, you can do that conversion by dividing the speed of light by the frequency. I think that's right.
Yes.
But I think part of the challenge here is that some of the wavelengths of these gravitational waves can be many. Do I have this right? Many light years.
Oh, indeed.
wide.
Indeed. Yes.
And so our LIGO ground-based observatories cannot detect those.
That's right. Absolutely.
Okay.
Right.
I mean, to be honest with you, Lou, I'm sure you would agree with me. It is truly amazing we're detecting anything at all. I mean, don't forget that Einstein himself spent 20 years prevaricating about whether gravitational waves actually exist, and then coming up with the conclusion that yes, they do, but we will never have the technology to detect them because they are so tiny. And he was wrong, of course. One of the rare instances when Einstein was wrong. So
I certainly agree. And if we make 2 jumps, one from hundreds of years ago, thousands of years ago, where all we knew about and could see was the visible part of the spectrum. Then all of a sudden we said, oh, there's more to that. So now our eyes open. Finally, we can see. But here's an area where we've been completely blind in the past. And not only that, but the light that we see from cosmology, as you've already mentioned, can take us back to about 380,000 years after the Big Bang. I think gravitational waves can go beyond that.
Indeed.
Is that right?
Well, if you think about this, electromagnetic radiation is radiation in a medium. It's in space. Gravitational waves are vibrations of space itself, which are not bound by the era before 380,000 years when light could not travel across the universe. So gravitational waves are not bound by that at all. So theoretically, it's thought that there were really, really big gravitational waves generated, immediately after the Big Bang during the inflationary epoch. Shall I say? Well, actually, before the Big Bang, during the inflationary epoch, theory says that there were a lot of gravitational waves that were generated that were not prevented from traveling across the universe in the same way that light was. So with sufficient technology, they would be able to be detected. Yes.
Cool stuff.
Yeah. Okay, Michael, tell us about the spacecraft then.
Yes, of course. Just bear with me a second when I can start this. Is that okay there?
Yeah, that's fine.
Right.
Just me get rid of our ugly mugs.
Okay. So this is going to be all about the LISA spacecraft, as Andy said that there are 3 of them, which are going to fly in the triangle formation. So here we go. So LISA is the Laser Interferometry Space Antenna, or LISA, which will be the first space-based observatory dedicated to studying the gravitational waves. In 2017, LISA was selected as the 3rd large class mission, L3, under ESA's Cosmic Vision 2015 to 2025. It was then adopted in January 2024, and construction will begin in 2025 as soon as the prime contractor has been chosen. Gravitational waves have been detected by ground-based laser interferometry since 2015, by experiments such as LIGO and the European Vigo Observatory. But these facilities are limited in size and sensitivity, meaning that they're only able to detect high-frequency gravitational waves from particular sources, such as emerging stellar mass black holes and neutron stars. So LISA is based on technologies that was flown in the LISA Pathfinder mission back in 2015, where the technology was tested successfully using lasers and a couple of golden cubes, which were in free fall inside the spacecraft. They was just successfully tested in that particular spacecraft. More of that in a moment. So, yeah. So as I say, LISA consists of 3 spacecraft flying in a triangular formation in a heliocentric orbit, traveling 20 degrees behind Earth. Each of the 3 LISA spacecraft contains 2 telescopes, 2 lasers, and 2 test masses. These are the golden cubes on each side, weighing roughly 2 kilograms. Gold-coated cube of gold and platinum, arranged in 2 optical assemblies pointed at the other 2 spacecraft. And this is a diagram of the orbit of the spacecraft. It doesn't actually not play. I don't think it'll play with it. It's actually an animation of the orbit, but as you can see, we've got Earth there. Can you see my cursor? You can see Earth there. The triangle of the spacecraft will be flying behind Earth by 20 degrees in the same orbit. Okay. I might be able to get a better slide of that. No, that's what I see. This is a picture of the golden cubes, which will be in a state of free fall inside a vault, if you like. And the technology will measure any alteration in the distance of these cubes from each other, which will tell us whether there's any gravitational waves present. So then just 4.6 centimeters on each side. Okay.
And it's worth pointing out that as a test bed, the LISA Pathfinder exceeded all expectations.
Yes, that's right. Yes, it did. Okay, so I'll just go on to the next slide. Yeah, and these spacecraft are going to be a long way apart. They're going to be 2.5 million kilometers between them. As you can imagine the ground-based observatories are some 4 to 5 kilometers in length. But these spacecraft, distance is no object by the sound of it. And you got a distance of 2.5 million kilometers.
So if you think of LIGO, each arm of LIGO is about 2 kilometers long. The longer the arms, the lower frequency gravitational waves you can detect.
Yeah, it's akin to the size of a mirror in an optical telescope, isn't it?
That's right.
The larger the size, the more definition you can get.
Yes.
Of the image, yeah. Okay.
So we go from 2.5 kilometer arms to 2.5 million kilometer arms.
Yeah, exactly. Yeah.
And this will allow us to detect supermassive black holes and what we talked about. Yeah.
So this is a slide from ESA itself, showing the way that the spacecraft are stationed behind Earth. This is how it will detect movement of these golden cubes will be detected by the lasers, and that will show us what waves are there.
Mm.
Okay, and the spacecraft is going to be launched. All three spacecraft will be launched at once on the European Ariane 6 rocket, currently planned for 2035. So there's quite a long time to wait as yet, but I'm sure it's going to be an interesting mission to follow when it happens.
Indeed.
Okay. And there's just a nice graphic showing the actual system in action, as it were.
Absolutely.
Right. Yeah.
Absolutely. Yeah. So thank you very much. That's a bit about the actual spacecraft. You talked about the Ariane 6. I should be very surprised if the Ariane 6 is flying in 2035, but that's another story. So
I think the earlier Pathfinder was also wasn't that a joint NASA mission?
Yes, it was.
Yeah,
it was.
But this is a completely ESA mission now, isn't it?
Yes, it's a 100% European mission now. Yeah. Okay, so there we are. So we've got that to come out. Yes, I know Sorry.
I have a comment. This is absolute. Lisa is absolute magic to me. These three spacecraft have to fly in tandem with the accuracy of the distance accuracy of less than the diameter of a helium nucleus.
Wow.
And when I years ago, when I was doing spacecraft orbit determination, we had to take into account all kinds of things, solar radiation, pressure. Even Jupiter could modify the position of satellites orbiting the Earth. How in the world do you do this in the solar system? It's magic.
It is. Well, I mean, don't forget that the gravitational waves that LIGO and Virgo and Kaggle are detecting, they're absolutely tiny. They're a tenth the size of a proton, which is it's absolutely crazy. But this is why humans are so clever. Once we put our minds to it and put our brains to it, we can achieve amazing things together.
Well, we watched the launch of Proba 3 earlier this week, and that is 2 spacecraft. I think they're a couple of 100 meters apart, or 150 meters apart, but it's actually acts as a coronagraph. One of them acts as a coronagraph, and it's blocking out the sun. But to be able to see as much as they want to see, the actual alignment has got to be, I think, what was that, Andy, within half the thickness of a thumbnail?
Yes.
Literally.
Yeah.
So to actually cover the sun and get as much of the corona in as possible, as close to the sun, it's got to be that tight an alignment. So to actually be able to do this, as you said, Lou, is absolutely astronomical.
It's magic.
Yeah, magic. Yeah. Witchery. It's witchery.
Don't forget the famous quote from Arthur C. Clarke. He said that any sufficiently advanced technology is indistinguishable from magic. And I think we're entering magic territory here.
Oh, yeah.
Definitely. So, I know that the launch is still 11 years away. And this is great for us because by the time that comes around, you won't remember we've done tonight, so we'll be able to do it again.
Yeah.
I'm going to save my presentation for the next 11 years.
Yeah. Good
You'll
idea.
be on an Ariane 7 rocket by then.
Yeah.
Or an 8.
Well, I don't even think there'll be an Ariane because,
No.
as I think I mentioned last week or the week before, Europe has put out a request for tender to 4 companies to develop a reusable European launch rocket.
Yes, that's true.
So I'd be very surprised if it's actually an Ariane. So there you go. Right. So gravitational waves, we will return to them, obviously, because, don't forget with gravitational waves, it's the birth of a completely new science. It's a completely new way of observing the universe. The universe is talking, and now we are listening, as somebody said. and it's all very exciting stuff. And we hope you're as excited about it as we are. Thank you to all of those who did join us live for the Proba 3 launch last week. The launch went off picture perfect. Everything was fine. The Proba spacecraft that Daz talked about are in orbit and being checked out and commissioned. Yeah. And we hope to get some results from that soon. So there we are. So let's move on. Quite an interesting choice by Donald Trump for the new administrator of NASA. The current incumbent, Bill Nelson, with the new president, he will be coming to the end of his term as NASA administrator. And Donald Trump has picked Jared Isaacman as the new administrator of NASA. You may know the name. Jared Isaacman was the commander of the Inspiration 4 mission, the world's first completely private spacecraft, space flight. And he was also commander of the Polaris Dawn mission in September. He's an incredibly interesting guy. He's a pilot of fast jets. He's done so much, as well as raising hundreds of millions of pounds for St. Jude's Children's Cancer Research Hospital. So this is Jared Isaacman. And we thought we would just have a chat about this appointment and see what anybody thinks. And viewers, if you have any views about the appointment of Jared Isaacman as the new NASA administrator, we'd love to hear your comments. Please put them in the chat. So let's start off with Lou, because I know you've got quite a strong opinion about this from what I've read of your comments.
Well, all right. So as a general statement, I am waiting for a NASA administrator who has a strong background in planetary and astrophysics research. Well, somehow I don't think I'm ever going to see that in my lifetime, but I keep hoping.
Has there been anybody who's come close, Lou, in your memory? Just out of interest?
Yeah, I'm thinking. Well, we had
Ed Stone.
Ed Stone was not administrator of NASA. No, he was head of JPL.
Yeah, JPL, of course.
Yeah, and that was a great choice. I mean, Ed it was absolutely phenomenal.
Yeah.
All I remember is better, faster, and cheaper. Get it done. That's all I can remember.
Daniel Golden.
Yeah.
Oh, Daniel Golden, yeah.
So
he was a disaster.
So here we are. This gentleman, this 41-year-old billionaire, has $1 billion. I guess that's some sort of qualification. He made his mark in the world on as the CEO of a payment processing system.
Mm-hmm.
Well, okay. I think it remains to be seen if he has any. I mean, okay, he wanted to go into space and he could pay his way to do that. That's great, but running NASA, I think it just remains to be seen. I don't know.
You're fairly pragmatic about it, then.
I'm a little bit cautious. Let's say I'm cautious.
Yeah. I think we all are in that degree. It's either a stroke of genius or it's going to be a disaster.
Yeah, definitely.
It all depends how. I mean, the thing is, myself personally, I've got lots of opinions about NASA. They're my heroes, but they're also their own worst enemy. And something really does need to change to do the science like you want to do, Lou. It's as simple as that. There is far too much bureaucracy and there's far too much excessive regulation, and there's far too much nepotism. And of course, my opinion of NASA is the big mistake, because it was formed by, was it Johnson? He formed NASA to counteract the industrial military might that could actually come out of this. So he said
NASA was formed in, was it 59?
Yeah,
58, 59.
Yeah, 58, 59.
The year I was born.
Yeah, he basically wanted it to stop becoming a industrial military complex, and he said we're going to form a civil body. It'll be run by civilians, but the purse strings will be kept by the government. And that was a big mistake, because basically it then meant that the government were dictating what can and can't do, what NASA can and can't do. And basically the military side of it still was a big part of it. So all along we've had to deal with, as I said, nepotism as regards certain companies. And now these were the old munition companies from the First and Second World Wars, which basically they supplied all the armaments, anything that flew, everything that was needed to fight a war. And they were the ones who were only in the position to carry on what was previous to NASA, which is NACA, and I can't remember what that actually stood for, but it was but they were the ones who were developing all the rockets and things like that, and they kept on being used because they were the only ones who could do it after the formation of NASA. Mm-hmm. But along come with that as well was the contracts they worked under, and these contracts have crippled NASA financially for ever since the formation of the NASA itself. So we'll carry on. I mean, people have tried to bring in the commercial companies to build the rockets. It's happening now with the Blue Origins and the SpaceXs, the Rocket Labs, and they're having some success. But they've been stifled, and it has been for a long time, because the stranglehold has been Boeing, Lockheed Martin, Northrop Grumman, and others, Rocketdyne, and people like that. And they've always the ones that have had the big contracts. And of course, the reason for this is when NASA was set up, it was supposed to be a national department, and basically it was spread out over all of the states, even Hawaii. So Boeing, Northrop Grumman, and everything, they're all set up in all different states. So everything was spread out over the whole of the United States. And that then brings in politics, because the senators want these companies to be successful. So I'm going to stop it there for the minute, because we are going to talk about the costs and that. So if anyone else has got anything to say, please join in. I don't want to...
Yeah. Roger, do you have any opinions on this?
Sorry. A lot of Trump's appointments have been very odd, very strange. This one seems all right, though. He seems switched on fellow. He seems to know what he's talking about. So,
well, I mean,
unusual
without wishing to get too political about it, looking at Trump's picks, cabinet, it's obvious he's actually trying to destroy the departments he's appointing those people to. But this one seems to be an exception, and actually could be a very, very shrewd move. But there we are. Roger, you got any comments?
Well, we just hope that we can actually get on and do what it was supposed to do without all this bureaucracy. And top man's jobs is what I say is what's going to happen. So we need a more broad-minded person at the top that can actually see the problems and get the situations put out to the right contract. So
absolutely,
we just gotta hope it all goes in the right way.
Yeah. Yes, Lou. So what were you going to say?
Can you all hear me?
Yes.
Yes.
Okay. I looks like I'm still backstage on my screen, but
right.
I often portray NASA as performing miracles on a shoestring budget. I certainly concur that there is bureaucracy. It's a federal government agency. How do you not? And there are regulations. Absolutely. But I have so much respect and pride for NASA in what they're able to do on really, I mean, yes, they're a $25 billion agency, but what they do with their $25 billion, I think, is remarkable. And I'm hoping, as I mull about the AGU meeting here and get to talk to a lot of my peeps from NASA, from NOAA, and so on, a lot of people right now are kind of running scared. And really are concerned about what the next 4 years is going to look like, and we don't know. But I don't know. I don't have any negative feelings about NASA at all. I just think they're remarkable. That's just my one viewpoint.
I think my personal opinion is that all of manned spaceflight should be left to the private sector, and NASA should concentrate on the science, which is what they absolutely excel at, along with Europe, of course. But NASA, NASA are, well, the list is endless, isn't it? Voyagers, for example, still going after nearly 50 years, still delivering great science. All the planetary probes. NASA are the body that have completed humans' initial reconnaissance of the solar system. And we have thrilled to those years. Cassini, Galileo, all of the Mars spacecraft, etc. NASA can do amazing things with science. And I think that human spaceflight is a bit of a red herring. It's done really not for any real scientific reasons, but to show Americans that something exciting maybe is being done with their tax dollars. We need to concentrate on, if we want to explore the solar system more, we'll do it with robotic spacecraft. And there's no real need at the moment for humans to go anywhere. That's my honest opinion. Yes, you could argue that it would be great to have some geologists on Mars to do things that robots can't do and do it a lot quicker. But I still think that the emphasis at NASA is far too much on human spaceflight rather than delivering science. But that's just my 2 penny.
Yeah, but that's only just come in since, we did the Apollo thing, and then for 50 years we did nothing. As regards human spaceflight, except for the International Space Station and lower Earth orbit stuff.
Yeah.
Sorry?
And the shuttle.
Yeah, that's what I mean. Low Earth orbit stuff and that. So that's what I was on about. But we've done nothing about interplanetary colonization and all that. And that's only sort of like raised its head since basically Elon Musk come on the scene. And of course, he's talking about going to Mars, and also we've got the Artemis talking about going to the moon. And these things are hard to do. But there was this lull of 50 years. And I would, don't get me wrong, Lou, I think NASA are an absolutely fantastic organization. I've got every respect for everybody who works there. But there's just too much of wastage. Think of all the science we could have done if we didn't have all these delays and all these overruns and these over costs that basically, in the real world, if somebody doesn't perform, they've got a target and they don't perform, they don't get them but money. But with NASA, even if you miss your target by 2 or 3 years, as long as you achieve the final point, you get a bonus. That doesn't happen in the commercial world.
No, it doesn't.
And this is taxpayers' money. That money could be going to do planetary science instead of rewarding people for being inept.
I think this would be a good debate to have. Yeah. I look at it just a little differently, Michael. I think the things that NASA does have never been done before.
Yeah, exactly. Yeah,
which means
this is
that,
what I said. Yeah, in
fact, in developing James Webb Space Telescope, which was way over budget and way over schedule, and is only there because of the hard work of Barbara Mikulski, our Maryland senator. Many of the technologies that they had to develop to get this thing working were not known when they started, they put in the proposal. So the way I look at it is, think of all we could do if we just had one fewer aircraft carrier.
Yes, true.
Oh, yeah.
Exactly, yeah.
That puts it into perspective.
I mean, NASA are just pushing the boundaries all the time, aren't they?
Yeah. But going back to what I was saying, if you were to ask an average American taxpayer, I'm guessing, I don't know, but I'm guessing that if you were to ask an average American taxpayer, what do NASA do? They would say they put people in space.
That's
Yes?
exactly right. That's
Yeah.
exactly right. We've asked that question. That's what people know.
People are mostly ignorant of everything else that NASA does with planetary science and astronomy and all the rest of it.
And Earth science and
Earth
avionics.
science, yeah, Earth
What are
science.
things that nobody knows about?
I mean, NASA is supplying, I don't know, you might know, you'll know better than I, Lou, but I read somewhere that NASA supplies about 80% of the world's climate data through its Earth observation programs. You know, which is crazy. And of course, Donald Trump tried to cancel that on the basis that if you're not observing climate change, it doesn't exist. That's true. It's absolutely true.
I know.
You know, it's like the ravenous bladder beast of trial, isn't it? If it can't see you, then it thinks you can't see him. So, you know, all of these things NASA is not known for. So people expect NASA to keep putting people into space because that's what they do. If you were to say, oh, the money's going to be spent on science, you watch how rapidly NASA would lose the support with the public. I think that's the basic truth of it, isn't it? I think so.
Well, I'd have to quote Carl Sagan yet again, where he said, we live in a society that is tremendously dependent on science and technology, where almost no one knows anything about science and technology.
Very true.
Yeah.
Very true. Sorry, Ian, you were going to say?
Alan was asking about Space Force. I don't know much about that, to be honest.
Oh, well, the Buzz Lightyears, yeah. When people think of this, a lot of the time they think of loads of soldiers going up in spacesuits and having a battle on the moon or out in space.
Is that not what it is?
Not all of it. Not all of it. Most of it is technological ways of defending your own assets.
Spacecraft.
So, and also to destroy somebody else's assets.
I mean, the Space Force is just really an extension of the Air Force, because Space
but just higher.
Because the Space Force looks after the spaceports, the you know, Cape Canaveral and that, and Vandenberg.
Well, I'm going to go out on a limb here, because when I heard that Trump was setting up Space Force, I thought, of course he is. That's exactly what Trump would do. Thinking it's going to be like stormtroopers, Star Wars, you know, because
I mean, there is that side of it, and they are developing it. But it's not as straightforward as what it is. Yes, there is going to be a contingent which will be, you know, going off supposedly fighting in space, but then you've got devised weapons that aren't going to give you a massive recoil, because you'll be flying off everywhere.
Wasn't there?
You know, it's just but the thing is, I like you, Andy. I was very skeptical about it. But then when they, you know, you think about China and things like that. Now I don't know whether it's paranoia or whatever, but they could go to the moon and then they could say nobody else is welcome. What you do?
This is exactly what I was going to say, that I didn't see the need for it initially, but now I do, as part of a national security strategy to maintain America's, I don't want to call it dominance, but certainly its influence in space, and ability to do, you know, things like go to the South Pole of the moon and not have a Chinese base there that tells them to sod off. So I do see the need for the National Space Force for national security. As far as America goes, I really see a need for it, because the Chinese, you know, they're coming on in such leaps and bounds, and they are not a democracy. They don't hold with democratic ideals. So they will, if they can get away with it, they will colonize the moon and prevent other countries from being there if they can. So this is why America needs an organization like the Space Force, I believe, to counter that. So there.
I mean, all the space treaties is basically all of them have said is space for all. No one can own space, no one can own property in space and things like that. But it's all voluntarily. You can sign up to something, but you don't have to abide by it, which has been proven. and it's really, I mean, if we want a proper, well, just expanding it a little bit, moving away from NASA, the ideal world is where the whole of the world, all the space agencies work as one.
Yeah.
And that would be the ideal thing. You wouldn't need a space force then. You know, only if vicious aliens came towards us, you know,
it's
with their snarly flappers.
Isn't it called the United Federation of Planets?
Well, yeah.
Not in my universe.
But no,
if you go there to the United Federation of Planets, remember that there's a neutral zone. You say nobody can own space. There's a neutral zone. There's the Klingon, you know, you don't go beyond that. They do that. They own pieces of space.
Oh, sorry, I dropped off for a moment.
Where are we going with this?
That was basically that was to do with Alan's question about the Space Force, because I mean the UK have got a Space Force as well. They're developing their own capabilities, and they have got personnel who are training at NASA. So,
as Barry says, whoever controls the high ground has the advantage.
Yeah,
absolutely.
Exactly. I mean, this is exactly that. But we're sort of like stretching away from NASA a little bit here. We could talk about this all day, and I think me and Andy over the years probably have done.
Oh, God, we've talked incessantly about it.
Yeah, so
basically, let's bring it back to Jared Isaacman.
Yeah, Jared Isaacman.
Firstly, his attitude towards private space flight is going to be a lot more favorable because Bill Nelson, the current administrator of NASA, at least up until relatively recently, was dead against involving SpaceX in anything to do with NASA.
Well, any commercial
and against private or commercial space flight. That much, you know, is obvious. He's on record. He really hated SpaceX a few years ago and did everything he could for them not to be involved with NASA. But times change. So I think Jared Isaacman will be good for commercial spaceflight. I see more commercial opportunities. He's already said as much, even before, you know, don't forget he has to be confirmed as the administrator yet. But if he is the new administrator, he's basically said that, you know, commercial spaceflight has got a much better future with NASA, and NASA will be more amenable to involving the commercial sector more, which I don't think they have a choice about, to be quite honest, but there you are. Secondly, I think, yes, I know he made his billions with you know, payment processing, and but let's not forget he has a vision for space, as shown by the Inspiration 4 and Polaris Dawn missions and the further 3 missions in the Polaris series that are coming up. My only worry for him is that he'll suddenly have to start playing a lot of politics.
Yeah, this is where it could fall down.
Corridors of Washington and getting involved in all that. Whether that will stymie his ability to carry on with the Polaris program, and whether he will end up a cynical, jaded administrator as a result of dealing with a Trump administration, whether he will keep his sanity is anybody's guess. But I hope so, because he seems a genuine guy with a clear vision for space and an excitement and a passion about delivering that and infecting other people with his enthusiasm. So all I want to say is let's wait and see.
Yeah. Wait and see.
Okay, well, I think we need to move on now. So if you have any comments about that, any of that, viewers, do put them in the comments. We'd love to get a conversation going with you about it, or put it in the comments after the show when it's on YouTube as a video. So, you know, we would love to hear your thoughts, obviously, as always. So moving on now. Lou, tell us again, for the benefit of Sandra for one, who gets a black mark in the book because she wasn't here at the beginning. Sandra, don't do it again. But Sandra has now arrived. Sandra has entered the building, and she doesn't know where you are. So please tell Sandra at least where you are, Lou.
It is third planet from the sun in the. Forget what arm we're in now. That's the problem.
Why did I
the Orion arm or the whatever it is. I am in Washington, D.C. at a conference at the American.
Oh,
Now he's gone. He's dematerialized.
Oh, dear.
Well, Sandra,
Alright,
let me just fill you in so you know why he's disappeared. It was nothing personal, Sandra, honest. It was just that he's in a hotel in Washington at the annual conference of the American Geophysical Union. And I think he's trying to get back in. He's on hotel Wi-Fi, basically, so please forgive him, because we all know what hotel Wi-Fi is like. Universally crap. So so now he appears to have just disappeared altogether. I think just let me see if I feel like Scotty in the transporter room. Just let me see if I can get him back. Here we are. I'm trying. I've got it. Hang on. I nearly got him then.
And rematerialize.
There we are. I got him. So can you hear us, Lou?
Earth calling Lou.
Earth calling Lou. Okay. Well, please bear with us, viewers, because the next segment of the show was going to be some slides from the conference of the American Geophysical Union, the annual conference, but not if Lou's hotel Wi-Fi is not up to it, I'm afraid. So perhaps if he doesn't come back, I'm sure we'll keep those for next week. While we're waiting for Lou, I'll just fill the air because it's definitely gone all together now. Sorry about that, but blame the hotel Wi-Fi. So
Shall I quickly do my cost of space flight quickly?
Yes, we're going to.
While we're waiting.
Let's do that. Can I just remind viewers just very quickly that next week is our last show of the year. We're not going to be here on Christmas Eve, New Year's Eve. Just repeat that. But we're going to leave some stuff on the channel to look at while we're not there. I'll tell you about that next week. Okay, Daz, please tell us what's this all about then?
Just bear with me then. It basically carries on from what we were talking about as regards the basically NASA and the cost of actually developing things and solar wavelengths.
Can you get that off the screen, please?
So anyway, let me just. I'm just trying to find my presentations.
So trying to get Lou back.
Oh,
Can you hear me?
Yes, we can hear you, Lou. Yeah.
Let's do Lou then.
Okay. Well, actually, I don't think we can because we can hear you, Lou. But although it says that we can only see your avatar. We can't see you.
Well, I just turned my camera back on. I was keeping it off to preserve bandwidth.
Let's try. Daz, can you quit that off the screen, please?
Sorry. Let me get rid of this.
Sorry.
Let me go back to studio.
Right. Okay.
Help. There we are.
Right. Okay. Let's go back to the normal view. Right. Okay, Lou, if you'd like to turn your camera on.
It is on, actually.
Oh, we're only seeing your avatar. So
this is awful. Well, look, forget my camera. Let's see if I can share my screen.
Okay.
And we'll try that. Screen share.
It would be a boring old world if everything always worked, wouldn't it?
Oh yes.
Yeah.
All right, let's see if you can see my AGU slide.
No.
No,
there's nothing there, I'm afraid. No.
This is frustrating. This happens to me all the time.
Sure.
I go away. I try to do too much. I was in a parking lot in Baltimore trying to do that. Oh my God. Okay.
Sounds like a job for NASA, I think, this Wi-Fi.
Yes, well, I will talk to NASA about it.
The A-team.
Well, if it's not going to show, then I'll try one more time.
Okay. Do bear with us, viewers, while we're trying to
share my screen.
Display this.
I'm glad I managed to join in just to see the comedy, says Sandra.
The perovskite broadcasting, as Derek just pointed out. Yes, indeed. But it would be boring.
Yes, exactly.
We didn't have one. This is the real world. You know, this is not a fictitious technological paradise where everything really always works and never has any problems. This is the real world.
Let's do this. I think it's much more effective with graphics. I could talk about AGU a little bit, but maybe we should postpone the bigger presentation till next week.
Yes, that would be great. That would be great.
So I will just say, as a kind of a summary, this is a conference for Earth scientists, heliophysicists, and people who study space weather, at least out to the Earth. Beyond that, for the heliopause and all of the heliosphere, probably not. Planetary scientists, and this is interesting, if you study planetary atmospheres above stratospheres, then you might be here. If you're studying planetary science in the troposphere of, say, Jupiter or Venus or Titan or the stratosphere, you tend to be at another conference. It's a strange mix. And nothing astrophysical. This is American Geophysical Union. So it's just a bunch of us crazy nerds, and NASA and NOAA and USGS and other agencies are here. It's an international conference, and it's
so there must be dozens upon dozens of organizations represented then, Lou, with that number of people.
Oh yes. There's an exhibitor area, which is as big as any major league soccer or football, in my parlance, stadium, which is filled with universities and private sector groups and federal agencies. I mean, it's just enormous.
Goodness me, I'd love to go to an event that big. I bet it's really impressive.
You should. You can go.
Yeah, you know.
Every 4 years, I think. This is a different conference. I think AGU occasionally has it outside of the United States in partnership with the EGS, the European Geophysical Society.
Oh, really? I didn't know that.
Europe. And sometime every 4 or 5 years, the Division for Planetary Sciences, which is a solar system research group, has their conference, usually in Europe. So I'll try to help identify some of those things for you.
Thank you very much. I'd love to go to something like that. I mean, I haven't been to an event for too long, and I'd love to go to something like that. So there we are.
Okay.
So anything else, Lou, useful you want to tell us?
I'm gonna keep everything else on hold until next week when I have the bandwidth to show you. Okay.
Thank you very much. Have you finished teaching for the year now? Are you going to be with us for all the show next week for our last show?
I've finished teaching. I just finished last night about 1 a.m. Grading the final papers, which thankfully looked a lot better than the first set of exams, which kind of scared me.
Good. Well done. That's credit to you, no doubt.
Here's the credit. It took a while for them to hear me, but I told them, you're allowed to have one piece of paper with anything you want on it on one side for the exam. You can have your notes.
Nice of you. It's very charitable.
And I said, when I make up the exam, I've got the exam on one side of me on the table, and I've got your study notes on the other side. It's not rocket science. Study the study notes because they will reflect what's on the exam.
Exactly.
I think they finally did.
Well done. Sheer contrast. I told my students that yesterday they were going to have an end of term exam. I told them a week ago. I reminded them in the WhatsApp group that we have, don't forget you need to study for your exam. Walked into the classroom yesterday and I said, so tell me, who hasn't studied for the exam? Everybody put their hands up. So
wow.
I thought, why do I bother? Never mind. Okay, well, we'll look forward to that then next week. Finally, well, not finally, but we're going to go over to Daz now. I mentioned earlier that a SpaceX booster has flown now a record 24 times. We hope it'll be a lot more, but that's the current record. A rocket booster first stage of a Falcon 9 rocket has flown 24 times. This is exactly why the cost of spaceflight has come down astronomically, because you can reuse them, which lowers the costs enormously. That is going to tell us a little bit about exactly how much that has lowered the costs of spaceflight.
Yep, that's what I aim to do. Right, now what's going to happen is I'm going to compare the costs of 4 rockets that have, over the years, I'm talking about Apollo, the Shuttle, SLS, and SpaceX. And basically, we're going to talk about the pricing of these per launch. We're not going to go into everything else. I might mention the overall costs and things like that, or maybe. But we're looking at the launch price. But what I've done is, as best as I can, is I've converted them to today's pennies. So in other words, the costs I'm going to give you is what it would have cost today, if that makes any sense to you. So the figures you'll be hearing is today's values. So here we go. We're just going to share this. Can you see that?
Yeah.
All right. Okay.
Yeah.
Then. So first of all, of course, we're going to start with the Apollo. And the actual cost of launching an Apollo Saturn V. And as you can see, the average cost per launch at today's prices, and remember there was, of course, we know we got to Apollo 17, but there was actually 20 of them. But the cost to actually launch the rocket itself was £1.1 billion. So that's quite a lot of money. That's even into today's terms. But what you've got to remember is this had never been done before. We weren't putting rockets like this into space. It had to be developed all in the space of 10 years, thanks to Mr. Kennedy, surprising everybody. We're going to send a man to the moon, not because it's easy, because it's hard. And these people had to do it, and this was their glory days. In fact, the actual the money that was actually given to NASA, its highest point was actually in 1966 when you compare it to the GPD of the country. So it was 1966, but after that it's dropped down and it stayed pretty low compared to what it was in those days.
Indeed.
And the estimated overall cost per launch, because we're talking about the capsule, we're talking about everything else that goes along with it, the launch towers, refurbishments, and everything else that goes along with it. It was between 3 billion and estimate between 3 billion and 7.27 billion per launch in today's money. So it wasn't cheap to do this. Space isn't cheap. Space is hard. But this was the beginning of the actual space race. Now we come to the space shuttle. And of course, we had 135 launches of the space shuttle between 1981 and 2011. The average cost of all the launches when you put them together was 506.5 million. Now, again, you see that has dropped dramatically from the Apollo launches. Again, because one of the major reasons is the shuttle itself was reusable. Unfortunately, the shuttle was basically, it suffered from lots of delays from its inception through to its building, through complications of the launch systems and things like that. But that's a completely different story. But the average cost in 2024 would be, well, basically just over $500 million. And the estimated cost over of all the launch would be 1.6 billion, because of course you've got the boosters, you've got the big tank, you've got all the fuel and everything else that would actually go along with that. So we've already seen a drop in the actual cost of launching the vehicle, but the overall costs are staying high. So now we've got the SLS. The estimate, I can't do an average on this because we've only had one.
One.
So the estimated cost per launch today is 2.5 billion, but the overall launch cost will be 4.1 billion pounds. That is astronomical in cost. And in fact, I think that has even actually been exceeded now. I think it's higher than that. And of course, it's been delayed for another year. So that's probably going to increase the actual.
I was actually reading recently, Daz, that estimate is definitely going to go up. So,
yeah, it's got to go up because it's been delayed again. So it's 4.1 billion. And again, you've got the boosters. The rockets were supposed to be the ones from the shuttle, but now we've used one lot of them, and now we're going to have to start building the rockets again, because and of course all this is expendable, and this is why the cost is so much, because to fly another one, you've got to build it from scratch.
Can I just interject there, just to show how crazy the whole thing is? Aerojet Rocketdyne have been refurbishing these ex-shuttle engines, and don't forget, these were originally owned by NASA. NASA have already bought them, and Aerojet Rocketdyne have been charging NASA $120 million to refurbish each engine. And NASA are paying for something they already own. It's just absolutely crazy how much NASA's being fleeced by these companies. Absolutely crazy.
And we've got to, you can't ignore the delays and the overruns and the costs. But this is what we mean by the fact that the cost of actual space is very, very high. But just as a comparison, we've now got SpaceX. Now, this year alone, they're expected to reach at least 136 launches. I've put that a question mark next to it, and that includes the Starship. There could even be one more Starship launch before the end of the year, if things go right. But we're talking about Falcon 9s, and the cost for the average cost. This is 2023. I did put 24 at the top, but when I looked further, these actually the costs for 2023. But you're talking per launch, $15 million to $30 million. That is a huge drop in price. And why? As Andy pointed out, it's reusable. The main booster is reusable. The fairings are reusable. The only part that is not is the second stage booster is not actually reusable. And this really slashes the price. And the more times you launch them, the costs get cheaper and cheaper and cheaper. Now, the reason there's a difference between 15 billion and 30 billion is that includes the super heavy Falcon. So that's, of course, and that's where you strap 3 Falcon 9s together, and 9 times out of 10, these are all expendable, because the reason that they're using the heavy is they need the extra boost, because they're either pushing something very heavy into space, or it's got to go further into space, into a higher orbit, and it needs to be pushed. And of course, that uses all the fuel, so there's no fuel for it to be able to do a re-entry. So these are expendable. But that is the cost per launch. Now, Starship launches are estimated to be between 10 and 20 billion. And again, this is because it's the actual boost. Well, you can't say it's reusable at the moment because they haven't reused anything.
Oh, sorry, Daz, what was that figure again? You didn't say 10 to 20 billion, did you?
10 to 20 million, sorry. Million. Sorry. Yeah, I'm getting me M's and me B's mixed up. But yes, 10 to 20 million. And this is all because it's expected to be reusable. And because it's such a bigger craft, it's going to be able to carry so much more cargo into space. So the cost per ton, or whatever you want to call it, per pound or whatever, is going to be absolutely reduced. And again, the more times that this is used, and they're not far off it now, it's only a couple more launches when they'll be retrieving both of these things and flying them again, that's actually going to come back. But just look at this. We're talking about millions. Nowhere does it in here mention billions. And this is why I do not understand why this is why SpaceX is most dominant now. It's one of the biggest customers of NASA, because they've really got nothing else to rely upon. New Glen's just going to hopefully come online soon. You've also got the Vulcan, which is struggling to get off the ground. That's ELA. But then again, they are still using. I mean, I know the New Glenn. They're saying they're going to try and reuse the booster, and they're going to try and capture it on a barge like SpaceX. But this will be the first time it's ever tried.
Yeah.
So for them to play catch up now, it really amazes me why everybody was so slow in actually trying to retrieve these machines to actually use again. I mean, the boosters for the space shuttle were supposed to be reused, but once they were dunked in the salt water of the sea, they become virtually useless. They had to be totally refurbed, taken apart.
Fair about it though, Daz. We should be totally fair. The technology to build reusable rockets did not exist during the Apollo era, the shuttle era. It's only recent technology, things like GPS, for example. Which is absolutely essential for reusing rockets to land them with pinpoint precision, as SpaceX does.
Yeah,
I think if you're a customer of a commercial company like Blue Origin or SpaceX or Rocket Lab or whoever, and don't forget Rocket Lab's heavy lift Neutron as well.
Neutron rocket,
If you're a customer, if you say, right, I'm a customer, I've got a satellite that I want to put into space and it weighs, I don't know, 200 kilograms, just a ballpark figure. How much is that going to cost me? The comparison you should be looking at is what's the cost of getting a kilogram of mass into orbit? Because that's what customers want to know at the end of the day. They're not bothered about the launch costs, although they will be paying them, but they're more interested in knowing, how much it's going to cost them. Now, it may amaze you to know that during the Apollo program, this is all adjusted for current money. In today's money, a kilogram of mass into orbit with Apollo cost about $217,000 per kilogram. The space shuttle, and I don't know whether anybody wants to guess what it would be if you adjust for current money. It was lower. The space shuttle, it cost about $150,000 to get 1 kilogram of mass into orbit. No, we've got to do this. Have a guess what the Falcon 9 is. Cost of getting a kilogram into orbit on the Falcon 9.
I would say probably about $1 million.
About $1 million. Any Michael, got any ideas? Roger?
50,000.
$500,000.
10 million.
Okay. 10 million per kilogram.
Oh.
So So
25,000.
I'll just go over the figures. The Apollo was $217,000 per kilogram. The Space Shuttle was $150,000 per kilogram. With the Falcon 9, $2,000 per kilogram.
Right. 2,000.
Yeah, somewhere between 2,000 and 3,000, depending. But basically, that is what SpaceX have done to the industry. We go from 217,000 with Apollo to 2,000 with the Falcon 9. And this is exactly, as Daz was saying, why SpaceX is so successful.
Yeah.
Because obviously, if you're a company who's built a satellite and you want to put it into orbit, who are you going to go with? So there we are.
Yeah, and of course, with SpaceX, have taken so many launches away, which were originally contracted to ELA and Blue Origin, away from them because they were contracted. They've ended up at SpaceX, and this is why there's this friction. But when I say I'm not, I can't understand why people haven't looked at reusability. I mean, in the last sort of like 3 or 4 years, that they've only just really started developing them. Other than the Chinese, and I think to the Chinese, I mean, I could be lying, but I think they're cheating a little bit because the rockets they're firing look amazingly like other people's rockets. Literally in design and everything. So There could be some espionage going on there, but what do I know? But yeah, it's only the Chinese, and they've had some success, but they still haven't mastered it.
No.
But people should have been once SpaceX started doing it, then everybody else should have. Oh, hang about, let's start doing this. But of course, the likes of Boeing, they were too invested in the SLS. ELA were doing their Vulcan, and they're all expendable rockets, so they're very, 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 very costly.
Yeah.
So, but this is what I mean. And if we can come, if Jared Isaacman can sort of like not force NASA, but point NASA in the direction of using commercial companies, then it would, hopefully the costs would come back down, and the money that NASA is getting then could be spent more wisely on the scientific stuff as well, which is what they're fabulous at, absolutely amazing at. You mentioned Voyager.
Yeah, absolutely.
It's these little machines. I mean, we were talking the other day about Prober. Prober, was it Prober 1? I said it only had a 2-year life expectancy, but they're only retiring it next year.
Yeah,
that's 25 years. 2001 it was launched. 25 years.
Yeah,
it's been running. It was only supposed to have 2 years. Prober 2. In fact, actually, Prober 2. I was actually looking at some of the data for that, the sun data for that today, because that's a sun observing thing, and that's been running for so many years. So the engineers and the technicians are, they're absolutely amazing. It's magic, as Lou says. Virgin on witchery. These things are outlasting everything else. But as I said, I think what I'm trying to say is that in the end of the day, I'm just disappointed that all these main companies were so slow. In fact, the likes of Boeing and Northrop Grumman and all that, they've got nothing in the pipeline for reusability. They're still not looking, and it just beggars belief. That's what I can understand. Anyway, that's my rant. Thank you for that. I just have that explained.
I mean, I think the bottom line is the cost of getting mass into space has just gone through the floor with SpaceX, and that's it, and that's why they're successful, and that's why last year they launched 85% of all tonnage put into space worldwide. So there you are. Okay. Yes, we've been having a discussion in the chat about various things, about this business of engineering and building things to last. Sandra says quite rightly we should not forget the Curiosity rover, and before that the MERs, the Spirit and Opportunity, which lasted years and years after their initial 90-day expected lifespan. So yeah, you're absolutely right, Sandra. So there we are, and nobody's. Yeah, all of them. No, it's not truly. It's not always true that the missions last as long as they were expected to, but mostly, these machines go on for years and years and years on their design lifespan.
I mean, we've now also started, and when they come to the end of their operational life, we're reconfiguring them to go on and do something else because they're still working.
Yeah.
I mean, you take OSIRIS-REx now. It's a Apophis Rex. It's on the way to another comet called asteroid called Apophis. So in June, not June. Was it? No, not Juno. Yeah, Juno, wasn't it? We can reconfigure that, or was it Galileo? No, Galileo. We plunged into Saturn, didn't we?
Yeah.
But yeah, anyway, Juno, I think it is. Yeah, because that's going on to some of the ice, the moons, isn't it now?
Oh yeah, absolutely.
So we can reconfigure them to do something else, because these machines, they're so well built by the technicians with technology which is old now, but they're still going. You've got to take your hat off to them. They're amazing.
Yeah. So there we are. Okay, well, let's move on. Time is getting on. Daz, I believe you've got a very brief solo update.
Yeah, unfortunately, just bear with me because I have to load it because I'm always scared of losing my. So just bear with me. Talk amongst yourselves for a second.
Yes. Don't forget we'll be back next week at the same time, 8 p.m. UK time. Don't forget, go and have a look at the Space Oddities website. It's https info@spaceoddities.space. And if you like what you see, then drop us an email at info@spaceoddities.space. Even if you don't like what you see, still drop us an email because we want to know. And any suggestions you have for anything that you would like to see on the website, gratefully appreciated. We've got a few ideas about how to expand it in the future. But, go and have a look at what we've got there at the moment. And any ideas or criticism, anything, just send it to info@spaceoddities.space and we'd love to hear from you. Not quite sure what we've got planned for our last show of the year next week. Something seasonal, we hope. But
Michael's doing a quiz, isn't he?
I'm doing a quiz, aren't I?
No, I've decided you're not. No.
Thanks.
Sorry, I'd
rather have my questions.
Yeah. No.
Yeah, Andy had a democratic vote, and he said you were not
Never
doing
again.
Yeah.
Oh,
Sorry. Yeah, Michael, do forgive me. I must be getting tired. Don't forget, it's an hour later here, and it's time for my Horlicks.
Yes.
So there we are. So anyway, next, just rewind. Forget what I just said. Next week we have the Christmas quiz for you. Michael will be doing the quiz next week here on Space Oddities. I've got to make it sound exciting now. So
yeah.
It's going to be the best quiz ever.
Oh, thank you, Andy.
Bestest quiz.
Oh, yeah.
Roger's shaking his head as if in some alternative universe thinking my quiz was the best. So there you are. Anyway, it's the quiz. Is there a festive?
It's the quiz of the year.
Oh no, it's not.
Oh, yes, it is. He's behind you.
Yes.
Does it have a festive content, or is it?
Oh, that's a good point. I'll have to think about that. So.
Yeah, no. Please do. You only got a week.
I know.
So have a think about that. It's quiz night next week. We did promise you we'd have another quiz before Christmas.
It won't take all night. Don't worry. It won't.
No. So do join us for the Space Oddities Christmas quiz, same time next Tuesday at 8:00.
Easier than the last.
We're going to have fun. And I'll be actually able to take part in the quiz for once. So
and all you'll need is a pen and paper.
There we are, viewers. You heard it there straight from the horse's mouth.
Not a calculator like Sam.
Yeah, exactly. Not a mainframe computer like somebody else mentioned.
Roger.
All mobile devices must be turned off.
Yeah, absolutely. Okay, so we got the Christmas quiz next week here, just to see us out with a bang of a cracker. At Christmas.
Oh, is that a big bang?
Hey. Okay, Daz, are you raring to go, mate?
Yeah, I'll just. Can you see that? I just got to.
I can. Let's get rid of our mugs again. There we are.
Right. Okay, then let me just.
El Teide, that's a mountain, isn't it?
Right. Okay, then here we go. And it's
Tenerife.
Yeah, that's right. It's in Tenerife. Can you see that full screen now?
No, but never mind. We can see it. It's okay.
Oh, okay then. Well, basically, this is how we left the sun. As you can see, we're using the NCO and Gong facilities. As Andy pointed out, you've got El Teide, which is in Spain, or actually in the Canary Islands, in Tenerife, and we've got Learmonth, which is in Australia. So on the left-hand side was how we left it last week. I do apologize for the quality, but of course, what you've got to remember is these are taken through the Earth's atmosphere. So they're going to be a little bit hazy. So on the left-hand side, we've got where we left last week. And then what we've got on the right-hand side is today. And as you can see, there aren't really that many sunspots. We didn't have many last week, and we've got, I think it's 7 altogether. I know you can only count 6 there, but there are actually 7. So you can see there isn't, not like we had a couple of weeks ago. Yeah, that's what we've got. But one thing I would like to point out, I keep saying about that they think that we've actually gone to started cycle 26.
Oh, yeah.
Now, one of the things you look for when the cycles begin is the sunspots will appear at the higher latitudes to begin with. and they will slowly migrate to the equator.
Yeah.
Well, of course, I've told you before, the north and south hemispheres have nothing to do with each other. They're doing their own thing. The northern hemisphere peaked, I do believe, about a month and a half ago. And now we've got the southern hemisphere coming to its peak. And this is why we get these double peaks. Because if you've noticed over the last couple of weeks, all these sunspots have literally sat just below the equator.
Yeah.
They've all migrated up. So that's just another thing we're looking at for things. So here we have the synoptic. One thing you will notice on here is we've got two very large.
Your slide's not advancing. Oh, have you changed the slide?
Yeah, I have changed the slide. Hang on, mate. Let me go back then, because I think I know what's going on.
Not to worry. These things.
There we are. There we are. We should. What about that?
No. No. Still nothing.
Don't know what's going on here then.
We can see them down the left-hand side.
Yeah.
That's any good.
Yeah. Can you not click on the image on the left-hand side, Daz? Of the thumbnail?
Well, the thing is, I'm trying to get to... right, here we go. Let's have a look at this. So,
there we
you
are.
see that?
Yeah,
that's right. Okay, for some unknown reason, it wasn't advancing in. I could see it, but again, this is the same situation we had the other day. So anyway, here's the synoptic map. As I said, these are the black holes. Remember, anything with an enclosed space with hashtags actually pointing inwards, they are coronal holes. And you can see we've got quite two big ones, and they've moved across all across the face of the sun in the last 10 days. And we had from, I think it's just gone off 3612, we did have an X-class flare, which I will talk about in a second. And this has been affected by these solar winds coming from these coronal holes, the enhancing. But also another thing we've been looking at is, if you can see these very long and very thick, you can see them definitely on the any imaging you can actually see. But these big, huge filaments. Now, this filament here, we think that maybe it's been around twice and it's actually held on, although this one's beginning to now look a bit tattery, and it could launch itself at any time. And if it does, trapped between those two coronal holes, that would definitely be Earth facing, and we will get something from that. So maybe just before Christmas, we might get a nice little surprise. But we're watching these, waiting for these to lift off. So we've got two coronal holes, very few actual active regions. There's another coronal hole there, look, because you've got the hashtags coming in, pointing into the center. I'm just looking at these two will be more effective, because in the autumn, positive gives us more, has more effect for some unknown reason. In the spring, anything with a negative, a coronal hole with a negative, in fact, that could be a positive as well. A negative charge will affect us more in the spring, and then in the autumn, it's the other way around. Anything with a plus sign will give us interact with the Earth far more. So anyway, that's what we're looking at the moment. So let me just come over here. Here's that. It was an X2.2 flare. This is now moved. This was 2 days ago, so now it's moved off onto the actual edge of the eastern limb. So it's just turning around. You can see faintly these filaments. You can see one just there. There's another one here and there. But and you can see the coronal hole is also this long here, and then it's just down in here where it's slightly darker. So that's what we're looking at. So that was the actual flare taken. Now, hopefully this will work. Let me just
You've knocked yourself off, Daz. You're off the screen a minute. You've unshared, as it were.
No, I'm still sharing.
No, we're just seeing us at the minute.
All right, then let's knock this on the head. There you go. Let's get rid of this. For some unknown reason, there's obviously something awry. But there you go. We'll knock this on the head. And
okay, thank you very much, Daz. So,
well, sorry about that.
That's all right. So these technical problems happen. So anyway, so that's it. We'll wind things down for now. Not a very active sun by the look of it, but
no, there's nothing exciting to come along. We've had a few M-class flares, but nothing's actually pointing towards us at the moment. And hopefully, very soon we should be getting some of the old friends turn around and come back from the other side. Yeah. So maybe giving us a bit of action. So yeah, sorry about that, folks.
That's okay. Don't worry.
Right.
Apologies, viewers. So anyway. We'll get these bugs out, don't worry. So we'd like to wind things down for the evening now. Don't forget Michael's quiz next week, our last show of the year. So we'll be popping the champagne corks. Oh, won't we?
When are we back?
Look. So anyway, we will see you hopefully next week. Don't forget the website. Don't forget to keep those images coming into the gallery. You can, of course, send them in over the Christmas period if you've got some time and you're out doing some astrophotography. Keep them coming in. We'll show them in the gallery in the new year, of course. So from everybody here at Space Oddities, we'd like to wish you a very good evening from myself, from Roger, from Daz, from Michael, from Ian, and from Lou, who unfortunately has disappeared due to hotel Wi-Fi in Washington. But he will be back next week, we hope. Yeah. So, from all of us at Space Oddities, have a fantastic. Sorry,
Andy. Before you go, just confirm we're off 2 weeks. We're here next week, off for 2 weeks, and then back. Is that it?
Exactly.
Right.
So we will be back the first Tuesday in the new year, the one after the 1st of January, of course. So.
Yeah,
we hope you've enjoyed the show. We covered a lot of ground of very different things tonight, but we like to do that for you on Space Oddities. So we're going to start planning the new year soon and putting things together for you. So thank you very much for watching, and we'll bid you a very good evening. Have a fantastic week. Stay safe. Look after each other, and we'll see you next week. So.